All right, so today is the last section in Chapter 1. It's 1.7. We're going to be looking at the solutions to linear, compound, and absolute value inequalities. So, first of all, a linear equation, we have inequalities and we have equations. So far we've looked at equations. It says a linear equation in one variable is an equation that can be written as ax plus b equals 0. That was a form for the equation, and there was an equal sign in there. Where a and b are real numbers, a is not equal to 0. A linear equality has one of the inequality symbols, a less than or equal to, a greater than, or a greater than or equal to. It says the solution set to a linear equation is just a single element, like x equals 7 or x equals 4, something along those lines. But the solution set to a linear inequality contains a whole range of numbers that would live on our number line. Let's look at the difference here. Notice that it says on the tip that if you want to review set builder notation and interval notation, see section R.1. We'll be looking at that as we go through our discussion here today. First of all, we have the equation x plus 4 equals 0. To solve that equation, you would subtract 4 from both sides, and so you would get x is equal to negative 4. To write that in the solution set, there's one element of negative 4 in the solution set. And if you were going to graph the solution set, it would consist of just a single dot at negative 4. Those are equations. Now, let's look at these two inequality examples. Here to solve for x, we would subtract 4 from both sides. And so we would come up with x is greater than or equal to negative 4. And so this is the solution set in set builder notation, and this is the solution set in interval notation. Either way, we want to graph the set of all values of x such that x is greater than or equal to negative 4. Back in high school algebra, you probably put a closed circle at negative 4 and you colored in all of the values to the right, which those are the ones that are greater than negative 4. But now in college algebra land, instead of a closed circle, we're going to use a bracket. A bracket and a closed circle mean the same thing, and that is to include the value of negative 4. Now down here on this next one, when we would subtract 4 from both sides, once again to solve the inequality, we would have x is less than a negative 4. So here we want all the values of x that are less than a negative 4. In high school algebra, you would have put an open circle there, and the values of x that are less than negative 4 fall back to the left of negative 4. But now we are going to, on the graph of our solution set, instead of an open circle, now we draw a parenthesis. Over here, this is the set builder notation. It's the set of all values of x, such that x is less than negative 4. Or, in interval notation, it's everything from negative infinity up to but exclusive of negative 4. One thing you need to notice is that here we have a bracket, and that had to do with the fact that we had an or equal to. It was a greater than or equal to. The bracket includes. Here we have a parenthesis, and that has to do with the fact that we just have a less than. So if you just have a less than or a greater than, you use a parenthesis. If you have a less than or equal to or a greater than or equal to, you use a bracket when looking at interval notation. Here's some properties of equality. The ones we're specifically going to be using to solve our equations are the addition and subtraction property of equality. That allows you to add or subtract something from both sides of an inequality and not change the truthfulness of the inequality. 5 and 6. These are the multiplication, and division properties of equality. I'm going to double asterisk this because remember, in an inequality, it depends upon if you are multiplying or dividing by a positive number. Here, let me kind of go over this. The less than, if you multiply or divide by a positive, that symbol doesn't change. Now here on this one, if you multiply or divide by a negative quantity, okay, we started out with A is less than B. What has to be true now is if you multiply by a negative quantity, to make it be a true statement, you've got to swap that inequality symbol around. Notice the less than now becomes a greater than on both of these. So in a nutshell, if you ever do the operation of multiplying or dividing both sides by a negative number or a negative quantity, you must swap the inequality symbol around. Otherwise, we are going to treat at least linear inequalities the same way that we do linear equations. Get constants on one side, variables on the other. Let's look at this in example 1. They want us to solve the inequality, graph the solution set. Graph means to put everything on a number line. That's what graphing means. Put it on a number line. Write the solution set in set builder notation. That's going to be the set of all, in this case, t values, such that blah, blah, blah about t. And then we're also going to put this in interval notation. That's with the parenthesis and or the brackets and negative infinity and positive infinity. Let's break all that down. So on number 10, the first thing we're going to do to get t on a side by itself is subtract 1 from both sides. So remaining on the left-hand side, we have negative 8t. All we did is subtract, so this less than symbol will remain a less than symbol. And 17 minus 1 is 16. Now the next thing we would do to solve for t is to divide both sides by negative 8. And ding, 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 did you see that I said divide by a negative? What that tells you you must do is swap this less than symbol around to now being a greater than. So t values are going to be greater than 16 divided by negative 8, which is a negative 2. Right? So now let's put everything they wanted us to do with this. First of all, let's graph the solution set. That consists of drawing your number line. Okay? Now you can label a whole bunch of points on your number line, like here's 0, 1, 2, and negative 1, negative 2, so forth. Okay? But I think it's just important just to put, the value in question here, the negative 2. So it's perfectly fine with me if you just draw your number line and slap a negative 2 on there. Okay? And you can do more detail if you want. Now, what we are asked to do is graph all the values of t that are greater than a negative 2. Values of t that are greater than or bigger than a negative 2 fall to the right of negative 2, so color in that portion of our number line. And because the symbol was just a greater than, we're going to put a parenthesis opening in the direction where the action is occurring. The orange thing here on our number line is called the graph of our solution set. And so what we're saying is that any value that would be in this orange shaded area of our number line would check back into our original equation. Okay? So for example, if I wanted to check, I think this is a pretty easy one to do. If I wanted to check 0, I'm going to go back to my original inequality and I'm going to see if it makes a true statement. To put a 0 in for t. So negative 8 times 0 plus 1 is going to be less than 17. Well, negative 8 times 0 is 0, and 0 plus 1 is 1, and is it true that 1 is less than 17? Yes. So that checks. Now, in an inequality, it's impossible to check all your solutions because we're talking about all the values that correspond to the shaded in area, and there are an infinite number. Okay, so I don't want to be here all day checking all of those. So we're just going to know that our solution set in set builder notation consists of the set of all values for t such that, and then you just write what you have over here. T is greater than a -2. That's the set builder notation. Now let's discuss the interval notation. Okay. To get interval notation, it is a lot easier just to look at the graph that we have above, okay? Now, if we look at the graph of this, we're going to describe all of these orange shaded in, this orange shaded in region. Read your number line as you would read a sentence from left to right, and nothing is going on here until we get to this parenthesis at -2. That's the very smallest value. Numbers that are just a hair bit bigger than -2. Then you put a comma and you say what's the largest value that is included in this set. Big, huge numbers, okay? So we're going to put the symbol of the idea of the largest possible number and always a parenthesis by infinity or -infinity. Because you can't actually include the number -infinity because it's not actually a number. It's just the idea of the largest number. So parenthesis, -2, comma, infinity is our solution set written in interval notation.